So we're back to the Heat Treat podcast. Today we have a power player all the way from Florida, GeorgeSmith, Executive Director of SBS Corporation. How's it going, George?
Good, Carlos. Thank you for having me.
Great to have you here. Super excited to learn about dynamic cooling of fluid dynamics, right? Today we're going to talk about air-cooled heat exchangers, cooling towers and closed loop, evaporated cooling, and all those questions that there are to be addressed about water cooling against air-cooled, water and quench oil, depending on what you do. George is an expert on the subject, been around the industry for a long time, manages one of the biggest companies, or maybe the biggest on their area. So it's going to be super fun. But first of all, George, can you just give us a brief introduction of your professional career, what you do, the company you actually lead, so the audience can actually get an idea of the big personality we have today in the show as a guest?
Well, we call ourselves your partner in the pursuit of perfect process control. And what that means is we want everything in your heat treat to run perfectly. And whether that's fluid dynamics, flow, cooling efficiencies, you get a new furnace in and your heat exchanger's not keeping up. We're the people that you call to make that much better. We've been open since 1974. My dad started the business back then. He recently passed and I have taken over for him, but I've been lucky to have him teach me everything I know for the last 9 years that I've been in the industry. And I'm having a blast doing it. I love the heat treat industry. We've had an outpouring of love from the entire community, which gave me a little bit of a perspective on the legacy that he's left behind. And yeah, we're just hanging in there and keeping it going.
So today we're going to talk about how to cool quenching media, mostly, right? Right. I know that you also have applications of how to cool gas, like on the endothermic generators. But why don't you give us a basic 101 explanation of what's an air-cooled heat exchanger, and then we can talk about cooling towers and closed loops and the difference. But if you were to explain what's an air-cooled heat exchanger and their applications on heat treat for IQs, for batches, for pushers, what are the difference, how to size them, right? Depending on the level of temperature, how do those work? And when everybody says, oh, it's just a chiller, right? There's a bunch of automation and process control that goes in electronically, like everything else nowadays. How those air-cooled heat exchangers or cooling towers, they have evolved to Industry 4.0?
Well, so if you are quenching into fluids that are above ambient air temperature, you can use an air-cooled heat exchanger. So basically, a very simple concept. We're blowing ambient air, or in some cases, evaporated air, which is a misting, over aluminum fin tubing, which allows us to cool the fluid inside. The formula for sizing them to do by hand would take about a day and a half and a full notebook. Luckily, we've been able to create a computer system that does this for us, so we can do it in a matter of seconds. So if you're quenching into a fluid, any fluid, you can use an air-cooled heat exchanger. We're also using them for nitriding furnaces to basically blow the air through what we call our nitrotherm, which is a lot of people in the industry are familiar with our endotherm, and that's what that concept was based on, which is cooling down endothermic gas. They're rugged. They last, where I was talking to a customer of ours in Sterling Heights, Michigan this morning, and their cooler is 28 years old in a week. And they're looking at cleaning it. I suggested they buy a new one, but they did. They last forever. They're rugged, and it's just the standard of the industry at this point. So basically how you do the rundown on cooling is based on your process temperatures. So if you're in the 70s, you're probably going to need a chiller. If you're in the 80s, you're probably going to need a cooling tower. Almost everything above that allows for an air-cooled heat exchanger. So the main temperatures of quenches that we see, especially in quench oil, are 140 to 150 degrees recovery. And whether that's maintaining on a continuous furnace or recovering on a batch furnace, those are the most common industry standards and what most of the OEMs build their furnaces to target.
So just a question there. Can you go deeper on what factors to consider when you're sizing a cooler? Because most of the people, they go like, well, I have this standard size, it will be okay, or I will make it, but there's not like a real calculation behind the choice. What are the calculations by hand or by computer right now that you have to take in consideration? I mean, the delta on temperature, the input temperature, the output temperature. What do you do?
So it really depends on whether you're running a batch process or a continuous process. On a batch process, we're talking about BTU removal per hour. So we're putting this much steel in. I mean, we can talk about a can-edge mesh belt furnace. They say we're putting 6,000 pounds in an hour, which equates to 3.1 million BTUs per hour. So we know we have to remove that constantly. When we talk about a batch application, we have to take into consideration tank size. So now we're talking how many gallons and how quickly do we need to recover that many gallons to this temperature. So we'll have an initial rise on, let's say, an AFC IQ furnace or a surface. Batch of steel comes in, oil spikes from 150 to 250 degrees. How long until the customer wants to put their next load in that furnace? And then we give a safety factor on that because heat treats run 24 hours a day, and that can tend to be strenuous, and then they get a new job and they want to run it on a different furnace line and it exceeds the capacity of our heat exchanger. So we have about a 15% safety net built into each of our coolers that allows for customers on that 90-degree day in the middle of the summer when that ambient air that you're blowing across the oil is hot to be able to cool down your quench tank in the same amount of time. So really it's batch furnaces. We're going to do 3,000 pounds every 2 hours. And this is our max ambient temperature based on where we are in the world. And also elevation is a huge factor. So Carlos, where you guys are in a lot of the business that we do with you, we have to take into account that some of the places are a mile high and we lose about a third of our air density at that height. So our cubic feet per minute of air that's going across the tube bundle in our heat exchangers, we're only getting 2/3. And we have to run that into our calculation. Otherwise, it just won't work. We'll be 33% undersized.
So this is how actually you designed the air-cooled heat exchanger. But also a very important factor is the distance from the tank to the air-cooled heat exchanger, right? Some people like to have it on the machine itself at the top, maybe one or 2 feet away, but there's some companies that they love to take it out of the building because of the noise, you name it, right? And then you have to pump the fluid over there. Of course, you have to calculate a pump size, right? But what other factors should be taken in consideration? Of course, you are going to need a higher quantity of oil or quench media because you have to fill those pipes. But, what can you tell us about that in your experience? What is important to take in account?
When you talk about pumps, you're talking about volume and pressure. So which translates to cubic meters per hour or gallons per minute. And then total dynamic head, which is your pressure. So you have to take into account every vertical run because at 100 feet away from your quench tank, if the pump's right next to the quench tank, you might need 150 foot ahead depending on how far it's going. And it also translates to meters and PSI. If you're 200 feet, well, sorry, but that 7.5 horsepower pump's not going to cut it anymore. Mm-hmm. And it's mostly dependent, when I talk about total dynamic head, that's how far a pump will pump when it's rated for straight up in the air. So if you ran a pipe straight up and you say this pump has 350 gallons a minute at 100 foot TDH, total dynamic head. Well, that means that you can run a pipe up 100 feet into the air from the pump and cut it off right there. That pump will put 350 gallons a minute out of that pipe. If you go up 10 more feet, that 350 gallons a minute is going to go down. And that's why we have to size them correctly. But the other big thing is pump inlets and outlets. So a long time ago, the pump companies decided to go from 1750 RPM as motors got more efficient to 3500 RPM. Now, all these pumps are cast components. So each pump has, a $40,000 casting and a forge. And they decided when they doubled the RPMs of the pumps to not increase their inlet and outlet sizes. So you'll have a 500 gallon a minute pump come with a 3-inch inlet and outlet. Well, that doesn't cut it at 500 gallons a minute. You have to match your flow to your pipe size, not what the pump has on the inlet and outlet. And we see this happen all the time. And we'll go into a facility and look at the pipes and just say, well, we're trying to get 350 gallons a minute to the heat exchanger, but you put 2-inch pipe in here. And our customers will say, well, that's what the pump had on it, rather than looking at the inlet and outlet of the heat exchanger, which is truly sized for the flow.
And one of the factors I have challenges on or heat treats and some of our customers are the filters. It's not the same to have a pump with a water, not filter, gaskets. I mean, the packaging, right? And an oil gasket or packaging. What's the difference that they have to take in consideration? Because if you have a heat exchanger, right, and you ask for a pump, you have to have a pump for oil, if that's the application, or water, if that's the application. I don't know about polymer or salt, because most of them, they ask for a pump, a general pump, right? And they just pipe it, but they do not consider the fluid that they're gonna pump through the pipes. Do you have some experience with that? Do you see that in the field a lot? People running
a unit seal because they pump oil through.
Yeah, the sealing of the pumps. That's what I meant.
Unit dissolves in oil. Mm-hmm. What we do is, and it's a good rule of thumb for all heat treaters, because a lot of people like to shuffle a pump around. We're talking about 24/7 operations, where you've got this pump that might not be running over here, but this pump broke on the other side of the shop. Let's swap them. We can't wait to get a new pump in. Well, in that case, then you should have all severe duty Viton silicon carbide seal faces. It's just a standard that works in our industry. The pumps last a heck of a lot longer. It costs a little bit more, but you can run those on polymer, quench oil, water, soluble oil and water, whatever, you name it. I mean, really, for fluid quenching, a severe duty Viton silicon carbide pump is perfect.
So I'm assuming that you see a lot these mistakes, that they just want to replace the pump with an available one. They forget about it and the seals start leaking.
Well, nobody has it written down what the seal is.
Mm-hmm.
They're not even looking at it. The pumps look the same, but they're not. When you look at the internals, one is severe duty and one's made for room temperature water. So we just say across the board, go severe duty, and that's what we always supply.
So severe duty. Okay, so now having this loop of air-cooled heat exchangers, how does the exchangers work? I mean, when you have a thermocouple on the quenching media, on the oil, right? And you have a set point. When the set point goes above the temperature, a pump is going to activate, right? We want to start pumping and cooling the oil quench on the heat exchanger, taking it back, right? But this is very constant. Can you give us a little more insight about this process? Because we have the PID control, we have on and off, is this on and off PID, or they call it high flow control? What's the technology used in order to cool, let's say, oil?
Well, that whole industry is changing a little bit right now. There's new technology available via what's called an electronically commutated fan, which we use intermittently on our heat exchangers. I have to admit that some of our longest customers can be resistant to that kind of a change because it causes change on their end. But these electronically commutated fans are really the future of the industry. It removes all the controls from the equation. So you've got a temperature transmitter in a heat exchanger. that is actually powered by the 460 volt fan, which has an internal transformer allowing it to power an indicating temperature transmitter. So that transmitter is sending a 0 to 10 volt signal to the fan, and the fan revs itself up and down and just has power connected constantly. So it's not on, off, which is very hard on any kind of motor. These regulate it, and that's the direction that we see the industry moving. But in the past, and what most people see is a Eurotherm controller in a panel or that sort of thing next to the quench tank. As soon as they quench a load, pump kicks on, heat exchanger kicks on, everything goes 100%. And with air-cooled heat exchangers, it's not needed because our recovery time is based on the ambient air temperature. So if it's 50 degrees out, that heat exchanger could be running at 50% versus 100% at 100 degrees. And it's not linear, but I'm using that as a kind of an easy example. And that's a really big goal that I think everybody needs to be working on, is conserving some energy and trying to make the heat treat industry, which is notoriously dirty on the world stage, a cleaner process and less energy dependent. We used to joke around when we were talking about these that the shop manager at a heat treat, he looks good if the power bill is high. That means he's got furnaces running like mad. And it might be time for that to stop.
You mentioned something very interesting, and I believe that's a taboo on the heat industry, that we run a very dirty industry. It's very severe, but it's very dirty when you have especially oil, because oil drips, it's messy on the floor, and when you burn it gives you a lot of fumes, right? And the products we're talking right now, air-cooled heat exchangers, they're actually for cooling oil most of the times, right? If you get a leak, it's very messy on the floor. If you get some fumes, if you get remains, there's a bunch of dirt or soot that accumulates on the piping. So we all know that the more you maintain a machine, you maintain a process, the cleaner it is. It gets dirty when we don't maintain it, right? But of course, you have to have a balance maintaining the machine and having enough resources to maintain all the plant. You're not going to have a guy maintaining a furnace, only an IQ furnace 24/7, right? You need him to be on the plant. What are like the most best practices that you try to that you actually preach to your customers? And some of them, they're really easy to do, and some of them you find most of the times that the customers just forget about it. The reason I'm telling this, air-cooled heat exchangers sometimes are on the ceiling, they're at the top of the machine, and nobody likes, or everybody forgets to crawl into a ladder because the machine is not at sight, right? What's your opinion on that?
There's two sides to it. We can talk about endothermic gas and quench oil.
Let's start with quench oil because then I want to begin with endothermic gas. But just when we're dealing with air-cooled heat exchangers, are the messiest, if you want to say, because they run oil. But what are the best practices that you try to, you tell your customers, if you do the ABC, you won't have any problems. But most of the times they don't do it.
It's all about correct installation. Our go-to is that you should not have to clean out an air-cooled heat exchanger for 10 years from the day that you bought it. If everything is functioning right under normal circumstances. I mean, there are obviously some outliers that have very dirty processes, lots of mill scale doing, then that's mostly on, 10,000 pound per hour line. But that would be an exception. If you have to clean that heat exchanger out within the first 10 years that you have it, there's something in your process that isn't right. There's either a piece of too small about restricting flow. Air-cooled heat exchangers are made to be self-scrubbing. So they're supposed to clean themselves. And they can't do that forever, but they can do that for 10 years. And I'm sure that a lot of people have realized that, especially when they realize all of a sudden that there's one on the roof. But they're getting the correct total dynamic head on a pump and the proper flow through the heat exchanger and basing that off of distance, restriction, pipe size. If you can get all of those things right, and we're here to help people do that, even if they didn't buy from us, that's how you maintain and make an air-cooled heat exchanger last forever.
So it's basically, if you follow this ABC, the air-cooled heat exchanger is going to last forever, or at least 20 years. Like your customers that they don't want to buy a brand new because it's been working for 20 years.
Carlos, I'm 32 and I can't tell you how many calls I get about heat exchangers that are older than me that we built.
Right. It's a classic battle. I don't know if that's a good problem to have, because you cannot, it's a great problem.
It is a good problem to have.
It's a good problem to have, right? But, it will be nice that they broke down a little more and they'll need to
the motors don't last as long as the coolers. So.
Right. Well, this is today's economy, right? The electronics products from 30 years ago, like furniture, it was designed to last forever, right? Not like right now, like a cell phone, you scrap it every 3 years, right? Average.
And no right to repair, but we stick to that. Everything that we build, you've got the right to repair it.
But I still believe our industry actually likes that. I mean, if you have a good product that it's reliable and it's going to take a long time, it's going to have a long lifetime, they respect that. There's a value in that in our industry. Now, I wanted to ask you about water cooling towers, right? I don't see them really often. I know some of the biggest companies, they have, like the bigger companies, the captives, they have water cooling towers some of the times, because they kind of unify all the cooling on the water tower. So when it's a cooling tower, a good way to go, when you have more than, let's say, 5-10 furnaces or other processes, when would you advise a company to go, hey, you don't need that many air-cooled heat exchangers, you need a cooling tower? What's the fine line?
The fine line would be anywhere that you are critical when you get near ambient air temperature. So with a cooling tower, you get basically, if it's 95 degrees out, you get a 10 to 15 degree difference lower on your processing water, which you can't do with an air-cooled heat exchanger because it doesn't use any kind of evaporation, unless we talk about cloud cooling, which we can get into, but that's a whole other area of interest. Cooling towers are great for things like water jackets. Our company's goal for forever has been to remove water from the heat treat industry, process water. That's been the goal from day one. But if you have to have it for a water jacket on a vacuum furnace, or for a bearing up on top, you can also go to an air-cooled heat exchanger. There really shouldn't be a reason to have water in the heat treat industry. Cooling towers were invented mostly for the HVAC and energy sector, and have just been adopted, but they're a pain. They require constant maintenance, constant monitoring. They can make everybody sick, with basically the bacteria that builds up. It's like maintaining a swimming pool on your premises.
On a tower, working on heights.
Yeah, right. They're constantly filled with algae. We build some systems that are used to clean cooling towers that use centrifugal action to remove solids that build up and create basically the ability for bacteria to grow. That's when you hear about these Legionnaires outbreaks and things with cooling towers. It's generally because of that, because of a dirty cooling tower. If you need processed water, if you need a quench that is recovered to, say, 75 degrees Fahrenheit, you're probably going to need a cooling tower or a chiller, which are also extremely expensive. But if you can run a quench about 110 degrees and up as your recovery temperature, you can use an air-cooled heat exchanger, no problem. Might be a little bit bigger than a cooling tower, but the cooling towers are notoriously difficult to maintain. And they basically just dissolve with age. And then also having water near quench oil is one of the most dangerous things you can do.
It is.
If you have a plate and frame heat exchanger and you don't get the pressures right and you have less pressure on the oil side than you do on the water side of a plate and frame or a brazed plate, and it gets worn down or something happens to it and you get a split, you're going to end up with a tank full of water. And if you don't catch it right away, you're going to light your whole shop on fire.
You bet. I hadn't even considered that.
It happened how many times?
It's amazing how everybody freaks out about having water and oil together on a quench tank. And if they're cooling on a water tower, I hadn't even considered that. That's dangerous. And so mainly the cons is that it's pretty maintenance intensive.
It is.
Right? It's maintenance intensive. It's on a tower. It's high. You get algae. You have bacteria. And versus running an air-cooled heat exchanger, right? That's where that's like the point in a nutshell. Okay, now let's go to gas cooling for endothermic juice. I mean, I believe they're not the same thing, but they're very similar. But I believe each one has their singularities. So how do we cool, and why do we cool, first of all, endothermic gas? I mean, because this is a question I get a bunch from operators, like, if we're making hot gas, and we're mixing air with hot gas, and we're gonna insert it on a furnace that is hot, what do we have to cool it down? That's a question I get asked a lot.
It's all about individual processes, but really it's about not having 1,000-degree pipes running through your entire building. And also all of the sensors that go on those pipes getting fried. So if you're measuring the dew point of that endothermic gas, trying to figure out what humidity content it is, if you're doing an ad cap, automotive batch, whatever your endothermic gas is being used for, you need to monitor it, because a lot can go wrong and you might ruin an entire load of parts or have a deformity down the line. And it could have been because of your endothermic gas not being monitored correctly. So we cool it down so your pipes are at 1,000 degrees or 1,500 degrees in some cases. And so that we don't ruin sensors. And then we can inject it into a furnace and have the furnace control the temperature rather than a random jet of gas coming in.
Mm-hmm. And what is different from cooling a quench media to gas?
So endothermic gas especially has the ability to crack. And so this, we put endothermic generator coolers right at the top as close to the retort as possible. We want to cool that gas from strictly really 800 to 400 degrees Fahrenheit as quickly as possible. That's the point at which we can cause carbon to remain in suspension inside of the gas. Otherwise, let's say you put it 20 feet away. If you don't insulate that pipe and keep that gas piping hot until it goes into the cooler, it cracks and fills all the pipes in your plant with soot. And that's the biggest one that we see, that people say, oh, well, no, we'll let it cool down a little bit on the way to the cooler. Don't.
They're going to fry the sensors and they're going to have a hot pipe.
Yep, hot pipe, and they're going to have a pipe filled with carbon soot.
Also, another difference will be that this cooler is going to be 24/7 on, right? Yeah. Because to the difference of an air-cooled heat exchanger that goes on and off, this is going to be on 100% all day long.
On and very hot, and our endothermic gas generator coolers definitely do not last as long as our air-cooled heat exchangers.
Okay, that's a good problem to have for you, right?
I guess that's, yeah. No, it's just the temperatures are so extreme. And again, it's another one where you could say, well, water cooling might be better. Well, water cooling at those temperatures is very explosive. So let's say your pump loses power. If you don't have emergency city water, that water jacket's going to explode.
And especially on generators with, if you don't have a generator, you cannot run operations, right?
Right, yeah, but now all of your furnaces are shut down.
Or are shut down, so, and it's a very high and hot, temperature to work at. So how do you maintain those coolers? And in the case that one of those goes bad or they break down, what's the proper way to address it? Companies have a unit on stock, or in these cases they can just replace the motor or something like that, because it's a less It's just a simpler application, but on a harder environment.
Yep. So all of our generator coolers are single engine.
Single engine.
Put it on the shelf is a great idea.
Well, and I know this is not the practice, but in the case, a motor breaks down or something, how, on your experience, and I don't want to put you on the spot with this question, but on your experience, how long can you still run your generator while you're doing that fix without cooling the gas?
Not long, and it really depends on what's downstream from it. If you have anything that would be impacted, I mean, if you could tell everybody that was working, that pipe's going to be red hot for a while. Great if you have transmitters on that line that are downstream from the cooler, you can't run at all.
Okay, so basically you're saying, if the cooler breaks down, just stop processing, fix the thing, which is an easy fix, and just get back online.
If your motor cuts out, it's a maintenance emergency.
Okay, it's a maintenance emergency. Okay, what are the most common mistakes that you see on this application with users that are a very easy fix?
Using the right material to run from the retort to the generator is a huge one. We recommend RA330, which is rolled alloys, stainless, that we use to make our top head adapter flanges, which are basically a flange that goes on the top of a retort that allows it to be easily plumbed into our heat exchanger. If you use anything under 316, really, but you're going to see a failure within months.
Right.
So if stainless steel.
So just to clarify this, when you have your pipe out of your endogenerator gas, some of the people they just go and they put carbon steel piping or flex that are not stainless steel 330, right?
Correct.
It will work for some days.
Yep.
Maybe some weeks you're lucky. Definitely they're gonna break in months, right?
Yep. Everything it's fine at startup, but it's not.
Right. Yeah. And I believe this is a great comment, George, because some of the customers, they get their generator in, and the utilities run are by the company, right? By the buyer of the machine, right? And the maintenance crew or the installation crew or maybe the riggers, they do not have the expertise on running hot machines, right? And they just go like, I'll just put a pipe there, regular carbon pipe. You're gonna lead the machine, you're gonna start processing gas, and it's gonna work. They're gonna liberate the machine, but something's gonna happen in 2 weeks or 4 weeks. So always use stainless steels 330, right?
Yeah, if we could have our wish, it would be that everybody used 330 stainless.
Right, and that's a very easy fix because it's a relatively, small pipe. It's not like big box, and it's gonna save you a bunch of money.
And stainless also works as an excellent insulation material versus carbon steel. Carbon steel has a much faster heat transfer rate, which allows that gas, if your cooler is further away, to get cooler before it gets to our cooler or whatever cooler you have. And like I said, we want that gas piping hot when we see it.
Good.
So having a 330 stainless pipe acts basically as insulation, so you don't have to insulate the pipe from the retort out.
Always, it's a great insulator, but it's I don't know is it by OSHA, but if there's hot pipes like that, does OSHA calls for insulating and put some guards on those pipes?
It depends where you are.
Okay.
We sell them all over the world. In most cases, no, because the endothermic gas generator cooler is mounted to the machine itself. So they're considered the same machine. So no, I see them all over the US that are not insulated from the generator retort to the cooler.
Also going back to the oil piping, because that's also hot. Not as hot as generator, but but those oil pipes are at touching range, right? Because those much people insulate their oil lines or not?
Not usually.
Not usually, right?
Before they run them straight out of the quench tank up to the ceiling and out to the heat exchanger.
Right, but you could actually bend on a pipe if you're on the furnace and you get your head burned.
For most oil quenches, they're not, you get a pretty big temperature differential between the inside of the pipe and the surface of the pipe. So if we look at a pipe that's 120 on the outside, it might be 180 on the inside. But I just happen to have this on my desk. that makes it OSHA approved.
Yeah, those pretty much. And those come with your heat exchanger, I guess.
They do.
Good, George. So we have covered air-cooled heat exchangers and cool exchanger for endothermic gas. Did we miss something that you think is worth just stating right now?
Monitoring.
Monitoring, great.
A huge thing, especially for looking back. So data has become free, relatively, but data doesn't cost anything anymore. So to store data points for ever, even if you're taking them every 5 minutes, you can graph those 10 years from now and look at them and look back if you've got a failure in the field, especially for aerospace and automotive. You can look back and see what was going on. We can look at your oil temperatures, your endothermic gas temperatures, dew points, furnace temps, ratio of nitrogen to oxygen, I mean, all of these things. And see what was wrong and look at them right on a graph and see if there was anything different the day before. And it's not hard to do. It's becoming very easy to do.
And it's relatively easy because, on automotive, on aerospace, the spec like CQA9 or
sure.
I don't know if that cap, they actually request to have a monitoring system for the process control, temperature, atmosphere. Right. So I assume, and I'm not an expert on this subject, maybe those SSI guys will know, that it will be very easy also to incorporate the cooling system to the main to the main general system, just to recall trends, data, like you're saying.
Right. That's why I was focusing on data is those local monitoring systems. It's a guy with a clipboard that's writing everything down every day.
And do you know if CQI9 or NatCap recalls to have constant monitoring on the delta T, on the delta, or the cooling of the oil quench?
Yeah, or QC9, but there is definitely sample taking. So you're recording certain measurements. And all of this can now be done automatically. You don't need a guy with a clipboard anymore. And cloud data storage, secure cloud data storage. And that's a big thing of what Super Systems does, is come in and digitize everything. And I think that our industry lags behind a little bit when it comes to that, comes to digitizing, because the furnaces last for 50 years.
Right, and it's not the same to be, you have white paper on a heat treat, it's going to be very dirty, very oil-filled and muddy, because the guys that are taking notes are basically the operators, right? And it's not like the cleaners
taking up valuable space.
Totally. Great. Well, George, it's been a ride, talking about air-cooled heat exchangers and, endothermic cool exchangers as well. Thank you so much for your time. If somebody would like to talk to George directly, we're going to leave his bio and link here on the post on the video, right? So we want to say thanks, George. And besides, you're a very young executive director in charge of the company. You say 32, right? And I tend to ask this question to elder guys, to older guys, but you're a CEO of a big successful company, right? And I respect that a lot. But if you could give an advice, and this time, let's switch it, right? Not to the younger, to the older guys, to the guys that have been to the industry for quite a round. You talking to them as a peer, what advice would you give them from a young CEO, right? That it's more dynamic, it's all about data, innovation, things like that, to an older CEO, right? That they listen, they're still leaders of companies. What would you like to share to them that will actually benefit them when dealing with younger generations?
They need to share everything they can. I think that coming from the exact position that you're talking about, I got to work side by side with my dad for the last 9 years. He taught me everything. And without a mentor like that, it would be impossible for me to be where I am right now. So share everything that you possibly can. It means the world to us. Having a mentor, and if somebody comes up to you and says, hey, would you mind being my mentor? This is a big focus of the YES program too. Say yes and do it. It's uplifting and worthwhile, and you build relationships that you probably never thought you would have with a younger person.
Thanks for sharing that. I think that's great advice. And I agree that 100% with you. I even have a mentor, right? Like you're saying. I also had the honor and the privilege to work with my dad. He taught me a lot, but I also have a mentor, which is a CEO in the industry, right? And for small things like maybe a negotiation, maybe a warranty, that it's not a big deal, but you need to know how to address it. You can give him a call, and I have this problem. How I know how, because most of the time you have the answer 80%, right? But you just need like a small push. Say just be careful with this, go with that. But thanks for sharing that. I believe it's a great advice, George. So thanks for being on the show. Super happy to have you here. I hope it's not the last time. And just want to remind the audience that we're having a weekly Heat Treat podcast by experts on the subject like GeorgeSmith, Executive Director of SBS, expert on air-cooled heat exchangers, and a lot of other applications regarding fluid dynamic. George, can you just do me a favor and go like this? We're going to subscribe. Here's the link. Hit like. And we'll see you on LinkedIn, YouTube, Spotify. If you don't have the video capability. And we'll see you next week on the Heat Treat podcast. See you, George.